All right, so we have discovered about the quantum physics. So now we would like to further explain about this photoelectric effect. So when we see this photoelectric, the word photo means light. Okay, photo means light, and electric that means the flow of electron. So this is something similar to thermal ionic emission. I remember we've learned in chapter 5 when a matter is heated. So the electrons inside the matter will get excited. It takes time to get excited, and then it can escape from the metal surface, right? So this is thermal ionic emission, and it takes some time to happen. But for photoelectric, is something similar to this thermal ionic emission, whereby if we emit a light, okay, the light onto a metal surface, so same also the electrons will gain energy, and if the light has enough energy for the electrons, so electrons will be escaped. So we call this effect as photoelectric effect. Okay, photoelectric effect. So so based on wave theory, okay, the kinetic energy of the released electrons depending on intensity. But the thing is, from what we know, okay, what we know that energy is actually closely related to the frequency. Okay, the frequency, yeah. So we want to break the belief, okay, the concept that we always think if the intensity, if it is even brighter, that means it has more energy, okay, for more energy for electron to escape. Actually, it is not correct to say uh because from what we know in quantum physics, okay, the energy is not depending on the intensity itself, but it depends on the frequency. Just like we always think that uh the number of people will determine whether the table can be lifted or not, but it's not the case. It depends on the age number. Okay, there's some certain requirement. Okay, so photoelectric emission effect is the emission of electrons. Okay, you can say electrons or photoelectrons from a matter by an electromagnetic radiation. So not necessarily must be a light. It can be UV ray. Okay, so as long as the EM radiation it has high energy and it can excite the electrons to escape, so photoelectric effect will happen. Okay, so this is how it looks like. How we gonna investigate the experiment? So what we're gonna do is we have a light source, and then we emit the light to the metal. So what happens is if let's say the light has enough energy, so the metal will emit the electron. So what happens is this electron will be attracted to the anode. Okay, the anode, which is positive. So when there's a flow of electron, okay, that means the current is flowing. So when the current is moving, that means the mini emitter there will be a deflection. Okay, there will be a deflection. So in summary, we shoot the light. Okay, we eliminate the light to the metal surface. So electrons will be emitted out. We call it photoelectrons. So these emitter photoelectrons will be attracted to the positive potential, which is anode. So this movement of photoelectrons from cathode to anode will produce a current inside the circuit. So that means the electric current will flow. So how do we know if the electric current is flowing? We have the mini emitter to show the value of the current. Yeah. All right. Okay, so now let's look at this simulation. We have a light over here. Okay, we have a light. So we can use infrared and then the visible light and then UV light. Okay, so the thing is we want to shoot the radiation. Okay, let's say let me try using red. Okay, let me try using red. Okay, so let me try start with the intensity. Okay, so if I increase the intensity, so you see it's like nothing happened. Okay, nothing happened, right? There's no electric current flowing, right? Okay, now if I change the color, okay, let's say I change the color slowly to orange, okay, yellow, still no happen, okay, and then green. So you see if there's green color, okay, green color, so we see these electrons coming out, coming out. Um, okay, so it goes slowly and then attracted to the anode. All right. Okay. If I further increase the color to blue, so we start to see the electrons actually getting more, not only just more, but the movement, okay, the movement is like faster. Okay, the movement is like faster, right? Okay. So uh so this is a probability thing, okay, not necessarily every time it will come out with how many, okay? So now let's go to UV light. Okay. Uh, Now you see the current actually as you go by, the current actually is increasing more and more. That means more electrons actually is flowing. Okay. Now the thing is, we want to prove that what happened is the intensity actually will not affect, okay, will not affect whether the electrons can be released or not. Okay, even though the light can be very dim, okay, can be very dim, but still it can allow the electrons to emit it out. Okay, but if let's say if I use this red, but if I only intensity 100%, still nothing happen. So what does it show that? It shows that if we want these electrons to get enough energy, it is not depending on the brightness, or we say intensity of light, but instead it depends on the frequency. Okay, it depends on the frequency of the wave. So if the frequency higher, so you get even more current. That means that you get even more more electrons. Okay, electrons going escaping. So they'll be escaping in a even higher energy. If higher energy, that means the velocity will be higher. Okay, so even I make it smaller. Okay, even though it's very dim, but still it can actually, okay, happen to release the electron. Okay, so we can try with other method also. Okay, so every single method that has a different value. Okay, different we call it threshold frequency. Okay, or we say the work function. It has the value for the electrons to overcome. Okay, to overcome so that it can be released out of the metal. All right. Okay, so let's go back to our slide. Okay, so the thing is so photoelectric effect is the emission of electrons. So when the frequency of light is low, so no electrons emitted. But if the frequency of light is higher, so electrons start to be emitted. Okay. So this thing I think I showed before about the about we if we use visible light, we cannot make this the plate the leaf to get deflected. Okay, but if we use the UV light, then even though it's very dim, but it can make the leaf to deflect. So this is because electrons are released when we use a UV light. Okay, so this is just a basic concept about photoelectric effect. And we can compare, okay, we can compare between thermal ionic emission and also photoelectric effect. Photoelectric effect is happening instantaneously, okay? But the thermal ionic emission, it takes longer time, okay? Because takes longer time to heat. Okay, so these are the four characteristics. Okay, the higher the frequency of photon, the higher the kinetic energy of the photoelectrons. And then there is a minimum frequency of light required for matter to emit the electrons. Okay, which is known as threshold frequency. Okay, we'll go for the Einstein the equation later. And then the kinetic energy does not depend on the intensity. Okay, so increase in the light intensity does not produce photoelectrons with a higher kinetic energy. Okay, so it does not depend on intensity. Yeah, all right. Okay, so I think that's it about photoelectric effect. We'll see you for the next video to analyze about the photoelectric effect equation.